much for joining. Today, we're going to be talking about a tool we've built to help investors transition towards a more sustainable future and allocate capital more efficiently to that end. We are Yan Nasinovich and myself, Raheem Shamsi, and we will be going through this presentation together. The problem we're solving is specifically for financial analysts and for sustainability consultants. Really, the challenge they face is that they have to spend hours and hours on end sifting through hundreds and hundreds of pages of company disclosures, specifically related to sustainability and climate change, in order to value those and model those in their financial analyses. And so, to help them save time, we've built them a tool to identify these risks from the textual data. Really, the impact is to help transition capital allocation towards a more sustainable future, where capital wins and climate wins will be realized. It's important to get some insight into the processes involved that consultants and analysts go through. Really, what happens in translating climate risks to financial metrics is that these consultants and analysts have to go through pages and pages of company disclosures and extract answers to questions that these standards such as TCFD have put together to make climate risk evaluation more standardized. And in doing so, like, they have to answer these questions not only for the company they're interested in investing in, but also for their competitors, and compare these answers in order to evaluate what the long-term risks and opportunities are, which seems like a lot of work and is. One stat that illustrates the why now for this opportunity is that 8% of investors in a survey group claimed that they would rule out investments based on climate risk in 2017. In 2018, that was 48%. So significantly up. We're specifically focusing on the consultants, even though the main larger customer base is like directly the investors. And that's because they offer us a wedge, a niche to target on, and to access the subject matter expertise that we lack. On the business side of things and the feasibility of this business, we believe that we can charge $1,000 per month in subscription because of the time we will save consultants, and that will lead to 31 break-even point of 31 paying customers, because the main costs are R&D personnel and also the amount of the server cost per customer. This is our product roadmap and strategy. I'll spare you the details, but like I've mentioned, the main part that we need to solve for is to help consultants and analysts attach a dollar value to climate risks and opportunities. And in doing so, step one is to extract climate risks and opportunities from company disclosures. There are other steps in meeting this goal, but then this was our primary focus, and we believe that this provides a lot of value because of the significant amount of time that is saved for the consultants and the analysts. I'm sure you've seen this architecture diagram before, so I'll spare you the details again. But the main variations from the standard architecture diagram is that our data set is pretty much question answer pairs from ESG reports that we've annotated. And that we trained our model, or fine-tuned our model on, and the fact that we're using the Haystack framework, which for a few reasons they provide a great tool to annotate question-answer pairs given the input texts, and so we found that easy, and we found that flexible for continuing doing some moving forward using user feedback, and as well they provide a great framework for building not only baseline models, but for quickly fine-tuning them based on these question-answer pairs. And so we thought they were a great tool. You will see it in the demo in a bit, but then really the product is a client-facing web app where the client gets to upload PDFs of these climate disclosures, which get sent to the AWS server, the backend of the application, which is a Flask app, where answers to questions are extracted. So we started off by building a Hugging Face model, actually, not a Haystack model, because it was pretty flexible and it was pretty quick to get something out of the box. We built it. We used a Roberta model, which has been trained on the Squad data set, We didn't fine tune it because we just wanted something quick and dirty. Really, the inputs to the model were the context, which is the text from the sustainability PDFs for different companies, for any company, specific company, and a TCFD question. So one of the questions that you saw in the previous slides, and then it spit out an answer to that question. And it was semantically satisfactory, the answer, but then the challenge was that it was really short. And really what was lacking was the context. And so in the next iteration, we used Haystack for the reasons I've spoken. Um, and we also, the model was then passed a context, and we tried to extract it was passed the entire text, and we tried to extract the context from which it got the answer. So really the paragraph that surrounds the answer in order to make this more explainable. And we got the feedback. The feedback we got was that this was a step in the right direction. But we realized we needed more feedback from subject matter experts. We also received the feedback that the answers were semantically correct, but then not correct for the specific field. And so we needed to fine tune it based on question answer pairs. And so that's when we started using Haystack for the generation of these question answer pairs and for the annotation. So yeah, the Haystack model we built was an Excel and Roberta model trained on the squad data set. And then we fine-tuned it using the question answer pairs and allowed the user to upload multiple documents, because they wouldn't upload one document at a time. They would upload a bunch of documents so that they could receive answers across the most appropriate answer. And really, what we learned was providing the context was valuable. Fine-tuning it helped because it helped a little bit, but then we needed to do much more of that. So we need to generate more question answer pairs. In terms of the model, we believe that there is a Finbert model that we could fine tune on these question answer pairs. There's a Finbert language model that we believe that we can attach a question answer head to then answer questions more accurately using the financial disclosure language. That's another step we can take. And really, what the other feedback we got was that the need to speed up inference, because it took 2.5 minutes to return answers to one question, and so that was quite a wait for the user. On the product side, we really need more, like I said, more feedback from subject matter experts to arrive at that MVP that users will pay for. And we're going to try doing that by gathering some feedback and then doing a mock sale to get these hard commitments. Yan will be going over the demo, but then here are links to our app, and here are links to our GitHub repository, Docker Hub repository.
Hi everyone, welcome to the demo video portion of our presentation about the Climate Risk Exposure Analysis Machine web app for helping investors understand whether companies are prepared for climate change risks. We worked out our initial model choices in a Jupyter notebook. Then we created the web app in Flask and posted it on our GitHub. After that, we created an image and we posted that on Docker Hub. After that, we deployed the web app in a Docker container in a C3 8x large AWS EC2 Spot instance with an Amazon Linux Deep Learning AMI. So here is our web app. You can upload as many PDF, docx, and text files as you'd like. The model looks through all of them for the right answers. Then you enter the name of the company, and then finally you select the question you'd like answered. So I'll do a little demo with ExxonMobil's 2017 sustainability report. And then enter the name here. And then the questions are the standard TCFD questions that Raheem discussed during the presentation. We'll pick number 1, does the organization describe the board's oversight of climate-related risks and/or opportunities? And then you just hit submit. Here you can see that the app returns the top 3 answers among the documents you uploaded. If you have suggestions for better answers, you can click this link and add your suggestions. We'll use your suggestions to improve our model. Each answer comes with the context from the document. And it can be from multiple documents. In this case, we only uploaded one, so it's just from the one. The model is currently being fine-tuned with our own custom annotations, but the training takes a few days, so we'll be deploying that soon. So if you go to the link, by the time you see it, it will likely be a new version of the model. And that's it. Please feel free to contact us on LinkedIn and let us know what you think.